Think of Chrome DevTools as a control room for evidence. Do not open random tabs and hope the answer appears. Follow a clean order. First, prove the visual problem. Second, trace the execution path. Third, inspect the request and response chain. Fourth, measure performance and memory instead of guessing. Finally, automate the same audit so the team can run it again on demand. That is the mindset for this video. The first practical skill is layout debugging. If the spacing looks wrong, do not start by editing the source file. Open Elements and change the box model live. If the problem is alignment, use the grid or flexbox editor instead of mentally simulating the CSS. And when the DOM is huge, search inside the Elements panel with text or a selector. This keeps you close to the real rendered page, which is where the bug actually exists. This part needs stronger teaching than the first draft. A lot of interface bugs only appear in hover, focus, active, or keyboard states. So force those states directly in DevTools and inspect the result. That is much better than trying to hold the cursor in the perfect place while the panel keeps disappearing. Then switch your attention to accessibility. The accessibility tree tells you what a screen reader sees, which is often very different from what a visual designer sees. And always verify contrast. Good UI is not only clean, it is readable, operable, and inclusive. Now move into sources. This is where you stop guessing about JavaScript and start tracing exact execution. A conditional breakpoint is powerful because it pauses only when the bug condition is active. A log point is useful because it gives you runtime information without editing the application source. And restart frame is excellent for learning, because you can replay the same function and watch the control flow again. Together, those three features remove a lot of chaos from debugging sessions. For React work, use React DevTools together with Chrome DevTools. In the Components tab, inspect props and hook state directly. That lets you test one branch without rebuilding the whole page. Then record a short session in the profiler and ask a simple question. Why did this component render? That answer often shortens the debugging cycle. The goal is to connect component evidence with browser evidence in one clear story. The next layer is the network panel. A senior engineer does not only check whether the request succeeded, they inspect how the page behaves while that request is pending. Use throttling to see your loading skeleton, optimistic updates, or React suspense boundary under pressure. Add a fetch or XHR breakpoint to pause the exact moment a critical request is triggered. And if the product uses live updates, inspect WebSocket messages as they arrive. That gives you the real data conversation, not a simplified summary. One of the most practical features in DevTools is local overrides. It lets you replace a live file or response with a local version on your own machine. That means you can test a broken payload, a missing flag, or a changed header without changing the actual service. For demos, debugging, and QA reproduction, this is extremely useful because the experiment stays inside the browser. You are not creating a new deployment just to answer one question. Performance work becomes easier when you stop talking in general terms and start measuring specific costs. Use performance insights for a guided read of layout shift and large contentful paint. Turn on paint flashing to see what the browser redraws after a change. And open layers when transforms, stacking, or compositing might be making the page more expensive than it looks. These tools make performance concrete, which is exactly what you need in reviews and incident debugging. Memory debugging is where long sessions reveal problems that short demos hide. Take a heap snapshot, perform the action, then take another one. In comparison mode, look for detached DOM nodes or retained objects that keep growing. That often means an event listener, timer, cache, or reference survived longer than the component that created it. This is the right way to investigate leaks because it gives you evidence instead of intuition. Under the DevTools interface sits the Chrome DevTools protocol. Python tools like Playwright can talk to that protocol directly. So instead of manually repeating the same audit, you can block third-party scripts, throttle the CPU, clear storage, capture a node screenshot, and collect runtime signals in code. That is how debugging becomes operational. It stops depending on one developer remembering a clever sequence of clicks. One habit that immediately improves speed is using the DevTools command menu. Open it with Command or Control, Shift, and P from there. Jump straight to full page screenshots, CSS overview, coverage, rendering diagnostics, or the frames per second meter. This matters because it turns DevTools from a crowded user interface into a searchable command surface. Once you build that habit, your debugging flow becomes much faster and more teachable. To present this clearly, keep a simple structure. Start with visual proof in elements, then show code proof in sources and React DevTools. After that, move into data proof through network, throttling, and overrides. Then measure performance and memory with paint flashing, layers, and heap comparisons. Finally, close with Python automation so the workflow scales beyond a single demo. That sequence is easy to learn, easy to teach, and easy to reuse.